Physics is the other sort of poster child for what we're going to do with all this CPU power. And there's some truth to that. I mean, certainly what we've been doing with the CPUs for the physics stuff, it's gotten a lot more intensive on the CPU, where we find that things like ragdoll animations and all the different objects moving around, which is one of these sort of raise the bar things. Every game now has to do this. And it takes a lot of power. Thanks. And it makes balancing some of the game things more difficult when we're trying to crunch things to get our performance up, because it's not, the problem with physics is that it's not scalable with levels of detail the way graphics are. Fundamentally, when you're rendering an image of a scene, you don't have to render everything at the same level. It would be like forward texture mapping, which some old systems did manage to do. But essentially what we've got in graphics is a nice situation where there are a large number of techniques that we can do that we can fall off and degrade gracefully. Physics doesn't give you that situation in the general case. If you're trying to do physical objects that affect gameplay, you need to simulate pretty much all of them all the time. You can't have cases where you start knocking some things over, you turn your back on it, and you stop updating the physics, or even drop to some lower fidelity on there, where then you get situations where you know that if you hit this and turn around and run away, they'll land in a certain way, and if you watch them, they'll land in a different way. And that's a bad thing for game development. And this problem is fairly fundamental. The aspect of if you try to use physics for a simulation aspect, it's going to impact the gameplay, things that are going to block passage, things like that. It's difficult to see how we're going to be able to add a level of richness to the physical simulation world that we have for graphics without adding a whole lot more processing power, and it tends to reduce the robustness of a game and bring on some other problems. So what winds up happening in the demos and things that you'll tend to see on PS3 and the physics accelerator hardware, you'll wind up seeing a lot of stuff that are effectively non-interactive physics. This is the safe, robust thing to do, but it's a little bit disappointing when people think about, I want to have this physical simulation of the world. It makes good graphics when you can do things like, instead of the smoke clouds doing the same clipped into the floor and, that we've seen for ages on things, if you get smoke that pours around all the obstructions, if you get liquid water that actually splashes and bounces out of pools and reflects on the ground, and this is neat stuff, but it remains kind of non-core to the game experience. And an argument can be made that we've essentially done that with graphics, where all of it is polish on top of a core game. And that's probably what will have to happen with the physics, but I don't expect any really radical changes in the gameplay experience from this. And I'm not really a physics simulation guy, so that's one of those things where a lot of people are like, damn id Software for making us spend all this extra work on graphics. To some degree, it's like, I'm like, damn all this physics stuff making us spend all this time on here. But I realize that things like the basic boxes falling down, knocking things off, bouncing around the world, ragdolls interacting with all that, that's all good stuff for the games. But I do think it's a mistake for people to try and go overboard and try and do a real simulation of the world, because it's a really hard problem and you're not going to give that much real benefit to the actual gameplay on there. It'll tend to make a game which may be fragile, may be slow, and you'd better have done some really, really neat things with your physics to make it worth all of that pain and suffering on there. And I know there are going to be some people that are looking at the processing stuff with the cells and the multi-core stuff and saying, well, this is what we've got to do, the power's there, we should try and use it for this. But I think that we're probably going to be better served trying to just make sure that all of the gameplay elements that we want to do, we can accomplish rapid rate, respectable, low variance in a lot of ways. Personally, I would rather see our next generation run at 60 frames per second on the console rather than add a bunch more physics stuff. I actually don't think we'll make it. I think we will be 30 frames per second on the consoles for most of what we're doing. anyways, but we're going to be soaking up a lot of the CPU just for the normal housekeeping types of things that we're doing. So while I've probably come off here as a pretty big booster of Microsoft on the 360 and their development choices, the potentially really interesting thing on the other side of the fence there with Sony is that they're at least making some noises about having it be a more open platform. And this has always been one of the issues that I've disliked about the consoles. I mean, I don't like closed development platforms. I don't like the fact that you have to go be a registered developer and you have to have this pact where only things that go through a certification process can be published. As a developer, I've always loathed that aspect of it. And Nintendo was always the worst about that sort of thing, and it's one of the reasons why we're not real close with them on there. But it's the reality of the market. When they sell these platforms essentially at a loss, they have to subsidize those to make them back on the development, on the unit sales of the software. But it's why I've always preferred the PC market in the past, that we can do whatever we feel like. We can release mission packs or point releases, we can patch things, and all of this good stuff that happens on the PC space that you're not allowed to do on the consoles. So Sony has been talking about more openness on the platform, and I'm not sure how it would work out there directly, but if you had something where if the PS3 became sort of like the Amiga used to be as a fixed platform that was graphics focused, that could be potentially very interesting. And Microsoft's certainly going to have nothing to do with that. I mean, they would, the idea of using the cheap platform to perhaps supplant Windows in some cases, they want nothing to do with that. But Sony might take that step, and I'm not sure how they would wind up reconciling it with the console software dynamics on there. But it could be really interesting. Actually, as a quick poll here, how many people have HDTV? Just curious. Okay, the console vendors are obviously pushing HDTV, but I've been hearing this since the Super Nintendo, way back when, had HDTV output support, and it's been over and over and over that it hasn't turned out to be a critically important aspect. But for a console as computing device, having a digital output HDTV may be one of the key things that makes that possible, because web TVs and such have always sucked. Nobody wants to actually do any kind of productivity thing on an NTSC TV output, but digital HDTV is really pretty great for that. And Microsoft got this big push that I'm somewhat at odds with them about minimum frame buffer rendering resolutions on the 360, and it's not completely clear how that pans out, but they're essentially requiring all games to render an HDTV resolution. And that may not be exactly the right decision, where if you've got the option of doing better rendering technology at less pixels and with higher anti-aliasing rates, that seems like a perfectly sensible thing that someone might want to do, but having a blanket thou must render at 720p or something, probably not. Some marketing person came up with that and decided it was the edict, which is another one of those things that I hate about the console environment, that you get some marketing person making that decision and then everybody has to sort of abide by it. I'm not clear yet exactly how that turns out. Obviously, things like Quake 4 is running good at the higher resolutions, but the next generation rendering technology, there's some things like, if it comes down to per pixel depth buffered atmospherics at a lower resolution, I'd rather take that than rendering the same thing at a higher resolution. But I'll be finding out in kind of the next 6 months about what I actually can extract from the hardware. So to change gears a little bit on the platform side, something that also ties into the whole development cost and expense issue. A lot of you probably heard that several months ago I actually picked up some cell phone development, which has been really neat in a lot of ways, where we're coming off Doom 3's development, which was a 4-year development process which cost tens of millions of dollars and had 100+ man-years of development effort into it. To go and do a little project that had about one-man year of effort in it, a little bit more, and was essentially done in 4 months. There's a lot of really neat aspects to that, where one of the comments that I've made in regards to the aerospace industry, talking about rockets and space and all that, is that the reason things have progressed so slowly there is because there's so much money riding on everything. If you've got a $500 million launch vehicle satellite combination, engineers just aren't allowed to come up and say, hey, I got an idea, let's try this. You don't get to go just try something out that might lead you to a much better spot in the solution space. You are required to go with what you know works and take a conservative approach that will have as low of likelihood as you are able to guarantee against failure. And while in the game development we're a long ways from that particular point, but when you're talking about tens of millions of dollars, it's not hundreds of millions of dollars, but it's not chump change either. And you look at game development process, and if someone is going to be putting up a couple tens of millions of dollars, there is a strong incentive to not do something completely nuts. They want to make sure that and even the people working on it, if you're going to work on something for 4 years, it's all well and good to say we're going to be at the vanguard of creative frontiers here, and we're going to go off and do something that might turn out to be really special. But if you spend 4 years of your life developing something and it turns out to be a complete flop, and you've spent all of your money and publishers don't want to give you another deal for your next one because you just had a flop, that's a real issue. And that is what is fueling the trend towards sequels and follow-ons and so on in the industry. And a lot of people will deride that and say, it's horrible that there's no innovation and creativity and all this here. We're getting Doom 3, Quake 4. I'll look at it and say, yeah, but they're great games. People love them. People are buying them and enjoying them and all that. But there is some truth to the fact that we're not going off trying random new genres. And the cell phone development was really neat for that, where we went and did a little kind of turn-based combat game. I think there's going to be a few people with some of the phones around here. You might be able to take a look at it. But the initial version was just tiny. It had to fit in 300K zip file, essentially, on here. So it was almost an exercise in pure design. It's not so much about the art direction, about how we're going to present this shock and awe impact that we've been doing on the high-end PCs. It's about what are going to be the fun elements here. How much feedback do you want to give them? What loot does the player get? How do you get to bash the monsters? And it's almost at the symbolic level because it's so simple. Now, after I started on some of that, it wasn't long before I have a backlog of like a half dozen interesting little ideas that I'd like to try on a small platform. And these aren't things that are anything like what we're doing. I mean, I've got some ideas for a rendering engine for a particular type of fighting game, or sort of a Combat Lemmings multiplayer game on cell phones. And so just cool things that we could never just go off and try on the PC space because it does AAA titles. We're not going to just be able to go and let's try doing a budget title or something like that. It's just not going to happen. We have the dynamics of our company. We need to continue to use the people that we have at the company. We're not about to say, well, we don't need level designers for this project. All of you guys, have a good life. Our projects are defined by the people that we have at the company. But the idea of having other platforms where you can start small at this one-man year of effort or so to just try out new things, I think is really extremely exciting. And there's two predominant platforms in the cell phone things, on cell phone for development. There's the Java platform and the Brew platform. And what's really neat is the Java platform is essentially completely open. Literally, I was looking at my cell phone and said, I'd like to try writing something on this. I just poke around online, download the development tools, download the documentation, and go upload a little program. And you can just start just like that. And that was sort of the feel that I had way back when I first sort of learned programming on like an Apple II or something. You just sit down and kind of start doing something. And sometimes I worry about people trying to start developing today, because if you start on the PC and you're looking at Doom 3 or something, and you open up MS Dev and say, where do I start? It's a really tough issue. We have been always, I've always consciously tried to help people over that gap with the tools that we make available for modding and the source code that we make available, specifically for that, to kind of help people get started. And I guess now is as good a time as any to segue on this. The Quake 3 source code is going out under the GPL as soon as we get it together now. And so there's a few actual key points about this. We're gonna cover everything this time. I know in the past we've gotten dinged for not necessarily getting out all the utilities under the same license and all that, but we're gonna go through and make sure everything everything is out there and released. All of the Punkbuster stuff is being removed, so the hope is that anyone that's playing competitively with released versions should be protected from potential cheating issues on there. And we'll see how that plays out. But one of the kind of interesting statistics that Todd and Marty told me just earlier today is that the entire Quake franchise, all the titles that have been produced on it, our titles, our licensee titles, have generated over $1 billion in revenue worldwide. And the source code that's going out now is the culmination of what all of those were at least initially built on. And I have a number of motivations for why I do this, why I've been pursuing this since the time that the Doom source code was released. One of them is sort of a personal remembrance where I very clearly recall being 14 years old and playing my favorite computer games at the time, like Wizardry and Ultima on the Apple II. And I remember thinking, it's like, wow, it'd be so great to be able to look at the source code and poke around and change something in here. And I'd go in and sector edit things to mess with things there, but you really wanted the source code. And that was something that later on, when it turns out that I've been writing the games that a new generation of people are looking at and probably thinking very similar things. Wouldn't it be cool to be able to go in and do this? And the original modability of the games was the step that we could take on there. But when we've been able to take it to the point of actually releasing the entire source code on there, it opens up a whole lot more possibilities for people to do things. And the whole issue about creativity in the development environment, that is one of my motivators for why I get this stuff out there, where I actually think that the mod community and the independent developer community, there are a lot of reasons why we can look for creativity from that level, where people can try random things, and there's going to be 50 things, and 40 of them are stupid, and some of them turn out to actually be the good, interesting ideas. Like it's amazing to look at how Counter-Strike has gone, which was somebody making a mod to make something fun, has become this dominant online phenomenon there. So there are also the possibilities of people actually taking this and perhaps doing commercial things with it. The GPL license does allow people to go make whatever game they want on this and sell it. You can go get a commercial publishing agreement and not have to pay in a dime if you abide by the GPL. And I'm still waiting for somebody to actually have the nerve to do this, to actually ship a commercial game with the source code on the CD. I mean, that would be really cool. But we always have the option of relicensing the code without the GPL. I mean, our code, you can't do this if you picked up random people on the net's additions to it. That stays GPL, and unless you go and get a separate license from everybody there, you're stuck with the GPL. But if you work with the original pristine source from id, you can always come back to us and say, well, we developed all of this with the GPL source code. We want to ship a commercial product, but we don't want to release our source code, so we'd like to buy a license. And we do that at reasonably modest fees. We've done that some with previous generation. That's certainly an option for Quake 3. But I do hope that one of these days somebody will go and do a budget title based on some of this code and actually release the source code on the CD. That would be a novel first. And the way I look at it, again, people are twitchy about their source code, more so than I think is really justified. There's a lot of sense that, oh, this is our custom super value that we've done our magic technology in here. And that's really not the case. All successful games, it's not about the magic source code in there. It's about the thousands and thousands of little decisions that get made right through the process. It's all execution. And while there's value in the source code, it's easy to get wrapped up in overvaluing what's actually there. And especially in the case of the GPL stuff, I mean, here we are, it's like, well, I'm releasing this code that has this $1 billion of revenue built on it. Don't you think it's maybe, a little bit self-righteous that the code that you've added to it is now so much more special and you're going to keep it proprietary and all that? There have been some hassles in the past about people that develop on the previous GPL code bases and don't follow through and release the code. And occasionally we've had to send, get a lawyer letter or something sent out to them. But, for the most part, I think a lot of neat stuff has been done with it. I think it's been great that a lot of academic institutions have been able to do real research based off of the code bases. And I am still waiting for someone to do the commercial kind of breakthrough project based on the GPL stuff. But previously I would have several people say, oh, but you didn't get the utilities licensed right or any of this stuff as sort of an excuse about it. But we're going to have all of that taken care of correctly this time, and anyone can kind of go with it to whatever level they want there. So I am, that's one of my sort of multi-pronged attack on hopefully nurturing creativity for gaming on there. And I do think making the canvas available for lots of people to work on is an important step. On the low-end platforms like the cell phone development, I think that I actually have sort of a plan that I'm hopefully going to be following through to develop a small title on the cell phone and then possibly use that, if it's well received, as a springboard towards a higher level title on there, which is sort of the opposite way that people are doing it now, where usually on the platforms like the GBA and the cell phone stuff, you'll see people that have a named title on some other high-end console platform, and they release some game with the same title that has almost no relevance to the previous thing, but you're just using some brand marketing on there. And I think that there's the possibility of doing something actually the other way, where if we do something neat and clever, or even just something stylistically interesting on there that people can look at and say, this is a good game, and you get 1 million people playing it or something, using that as your kind of negotiation token to go to a publisher then and say, all right, now we want to go ahead and spend the tens of millions of dollars to take this to all the high-end platforms and really do an awesome job on that. And we'll see over the next year or so if any of that pans out. But that's, I think there's a better chance doing that than sort of your random cold call, where id Software is in sort of a unique position of we can just say this is the game that we're going to do next, and publishers will publish it because we have a perfect track record on our mainstream titles. They've all been hits and successes. But even in a lot of the companies that we work with, sort of our partner companies and companies that we help on the development projects and try to help get projects going. It's tough to pitch a brand new concept. It's pretty easy to go ahead and get titles developed that are expansions and add-ons and in themes and sequels to the stuff that's known to be successful. But starting something brand new is pretty tough. So I think that things like starting from mods or small-term game platforms is an exciting idea for moving things a little bit forward there. But on the downside, the pace of technology is such that while our first cell phone target was for this 300K device, we later made an upscaled version for one of the higher-end Brew platforms, and it's 1.8 megs. And I looked at this and said, well, we upscaled all of this, but if somebody targeted a development platform or targeted a game development specifically for the highest end of the cell phones now, you're already looking at $1 million game budgets. And given a year or two, we're going to have PSP level technology on the cell phones, and then a couple years later we'll have Xbox, and eventually you'll be carrying around in your hand the technology that we currently have on the latest consoles, and then people will be going, is it worth $20 million to develop a cell phone game? So this is a treadmill that really shows no signs of slowing down here, and the issues are going to keep, they're going to continue to be problems in the future, and I'm not sure how you scale down much further than that. So there might only be this window of a year or two where we've actually got the ability to go out and do relatively inexpensive creative development before the bar is raised, as the saying goes, over and over again, and you're stuck to huge development budgets, even on those kind of low-end platforms. So in terms of where the things that I think hardware should be evolving towards, honestly, things are going really well right now. I don't have the quibbles that I make about the exact divisions of CPUs and things like that on the consoles. They're really essentially quibbles. The hardware's great. I mean, everybody's making great hardware. All the video card vendors are making great accelerators. The consoles are well put together. Everything's looking good. The pet peeves, or my wish list for graphics technology at least, I've only really got one thing left on it that hasn't been delivered, and that's full virtualization of texture mapping resources. And this ties in with a number of things that there's a fallacy which has been made over and over again. It was being made yet again on this console generation, and that's that procedural synthesis is going to be worth a damn. People have been making this argument forever, that this is how we're going to use all of this great CPU power. We're going to synthesize our graphics. And it just never works out that way. Over and over and over again, the strategy is bet on data rather than sophisticated calculations on there. It's won over and over again. And if you basically want to unleash your artists and designers more and more. You don't want to have your programmer trying to design something in an algorithm. It doesn't work out very well. I mean, this is not an absolute dogma sort of thing, but if you've got the spectrum from pure synthesis that like to make their mountains and fluffy clouds out of iterated fractal equations and all this, down to pure data, which is nothing but rendering models that are already pre-generated, I'm well off towards this side where I believe in simple combinations of extensive data. And the texturing is one of the areas that I think we can still make radical improvements in the visual look of the graphics simply by completely abandoning the tiled texture metaphor. And even in the modern games that look great for the most part, you still look out over these areas and you've got a tiled wall going down that way, or a repeated grass pattern. Maybe it's blended and faded into a couple different things. But it's still, the essential way to look at it is that texture tiling, the way it's always been done, texture repeats, is a very, very limited form of data compression, where clearly what you want is the ability to have exactly the textures that you want on every surface, everywhere. And the visual results that you get when you allow an artist to basically paint a scene exactly as they'd like, that's one of those differences where a lot of people are sort of wondering what's going to be the next big step, where obviously you look at the Quake 3 or the Doom 3 technology versus the Quake 3 technology. We took a massive leap in visual fidelity. Now, there's a ton of graphics algorithms that you can work on that will give improved quality in similar models that we can take forward, and a lot of them are going to be pretty important. High dynamic range is the type of thing that can make just about everything look better to some degree, and you can do all the motion blurs and subsurface scatterings and grazing lighting models and all of this. And those are good, but they're not the type of thing that, for the most part, when you glance over someone's shoulder walking by, that it makes what's on the screen look radically better. And unique texturing is one of those things where you look out over a scene and it can just look a whole lot better than anything that you've seen before. Now, what we're doing in Quake Enemy Territory is sort of our first cut at doing that over a simple case of where you've got a terrain model that has these enormous, like 32,000 by 32,000 textures going over them. And Already, they look really great. There's a lot of things that you get there that are generated ahead of time on there, but as the tools are maturing for allowing us to let artists actually go in and improve things directly, those are going to be looking better and better, and we're using similar technology, kind of taking up a step in our next generation game. And I'd really love to apply this uniquely across everything. It'd be great to be able to have every wall, floor, and ceiling uniquely textured where the artists are going around slapping down all of these decals all over the place. But it's a more challenging technical problem where there's a lot of technology that goes on behind the scenes to make this flat terrain thing, which is essentially a manifold plane, uniquely textured with multiple scrolling textures and all this stuff going on behind the scenes. It doesn't map directly to arbitrary surfaces where your locality can't necessarily tell you everything. Like an obvious case would be if you've got a book. A book might have 500 pages. Each page could have this huge amount of texture data on there, and there's no immediately obvious way for you to know exactly what you need to update and how you need to manage your textures. And there are lots of people who have spent lots of time in software managing these problems. You get some pretty sophisticated texture management schemes, especially on the consoles where you've got smaller granularity and control over everything. But the frustrating thing for me is that there's a clearly correct way to do this in hardware, and that's to add virtual page tables to all of your texture mapping lookups. And then you go ahead and give yourself a 64-bit address space, and then if you want, take your book that has 500 pages, map it all out at 100 dpi on there, and give yourself 50 gigs of textures there. But if you've got the ability to have the hardware let you know, okay, this page is dirty, fill it up. Whether it's fill it up just by copying something from somewhere, or more likely decompressing something, or in the case of a book, using some domain-specific decompression. I mean, you could go ahead and rasterize a PDF to that and actually have it rendered just like anything else. This is one of these things which has seemed blindingly obvious and correct to me for a number of years, and it's been really frustrating that I haven't been able to browbeat all of the hardware vendors into actually getting with the program on this, because I think this is the most important thing for taking graphics to the next level. And I'm disappointed that we didn't get that level of functionality in this generation, the ability to go ahead and what you'd want it to do is if it's missing the page, not mapped in, it just goes down the bitmap chain and eventually maybe stops at a single pixel, whatever. It's all completely workable. There's some API and OS issues that we have to deal with and exactly how we want to handle the updates, but I think it's a solvable problem and we can deliver some really, really cool stuff from this. And the only other thing that I have to say about graphics now really is that getting people to concentrate more on the small batch problem is important. And Microsoft is focusing on that for Longhorn to try and make that a little bit better. But it's a combination hardware-software thing where ideally you want your hardware to be, or your API to be a direct exposure of what the hardware does, where you call something which sets a parameter, it becomes store these 4 bytes to the hardware command buffer. And right now there's far too much stuff that goes on, which winds up causing all of the hardware vendors to basically say, use large batches, create, use many more, either use instancing stuff or go ahead and put in more polygons on your given characters. But the truth is that's not what makes for the best games. I mean, given a choice, we can go ahead and have 100,000 polygon characters, and you can do some neat close-up stuff and everything on that, but a game is far better with 10 times or 100 times as many elements in there. For instance, we're a long ways from being able to render this hall filled with people, with each character being detailed, because there's too many batches. It just doesn't work out well. And that's something that the hardware people are aware of, and it's evolving to some correction, but it's one of those issues that they don't like being prodded on it, because hardware people like peak numbers. You always want to talk about what's the peak triangles, the peak fill rate, and all this, even if that's not necessarily the most useful rate. And we suffer from this on the CPU side as well, with the multi-core stuff going on now. But overall, I'm really happy with how all of the graphics hardware stuff has gone. The CPUs, and it's sort of falling off my list of things about 4 or 5 years ago, I basically stopped bothering talking with Intel and AMD because I thought they're doing a great job. I really don't have much of anything to add. Just continue to make things faster. You don't have to add quirky little things that are game targeted. And the last year or two, even the video card vendors, I continue to get the updates and look at all of these things, but basically it's, good job, carry on and get the damn virtual texturing in, but that's about it. So life is really good from a hardware platform standpoint on there, and I think the real challenges are in the development management process and how we can continue to both evolve the titles that we're doing and innovate in some way, have the freedom to do that. And that's probably a good time to go ahead and start taking some questions. So I guess I'll probably just, if I can see people, I'll take questions from the audience. Yeah. Green shirt, yeah. Okay, so the trade-offs when you are developing for multiple platforms. It's interesting in that the platforms are closer together now than they were in the upcoming generation than the current generation. There's a much bigger difference between Xbox and PS2 than there is between Xbox 360 and PS3. There were clearly important design decisions that you would have to make if you were going to be an Xbox targeted game or a PS2 targeted game, and you can pick out the games that were PS2 targeted that were moved over to the Xbox, pretty clearly on there. That's less of a problem in the coming generation because both a high-end PC spec and the 360 and the PS3, they're all ballparkish performance-wise. Now, the tough decision that you have to make on there is how you deal with the CPU resources, where you might say that the best, if you want to do the best on all platforms, you would unfortunately probably try to program towards the Sony cell model, which is isolated worker threads that work on small little nuggets of data rather than kind of pure threads. Because you can take threads like that and run it on the 360. You won't be able to get as many of them, but you can still run, you've got 3 processors with 2 threads, or 3 cores with 2 threads in each one. So you could go ahead and make a game which has a half dozen little worker threads that go on the cell processor there and run as just threads on the 360. And a lot of the PC specs will at least have hyper-threading enabled. The processor is already twice as fast. If you just let the threads run, it would probably work out okay on the PC, although the OS scheduling might be a little dodgy for that. That might actually be something that Microsoft improves in the long run. And that's kind of an unfortunate thing that would be the best development strategy to go there, because it's a lot easier to do a better job if you sort of follow the pure thread model that you would have on the 360, but then you're going to have pain and suffering porting to the cell. And I'm not completely sure yet which direction we're going to go. The plan of record is that it's going to be more the Microsoft model right now, where we've got the game and the renderer running as 2 primary threads, and then we've got targets of opportunity for render surface optimization and physics work going on in the spare processor and the spare threads, which will be amenable to moving to the cell. But it's not clear yet how much the hand feeding of the graphics processor on the renderer, how well we're going to be able to move that to a cell processor. And that's probably going to be a little bit more of an issue because the graphics interface on the PS3 is a little bit more heavyweight. You're closer to the metal on the Microsoft platform, and we do expect to have a little bit lower driver overhead. People that program directly on the PC as the first target are going to have a significantly more painful time, although it'll essentially be like porting a PC game like we did on the Xbox with Doom. Lots of pain and suffering. You take a game that's designed for 2 gigahertz or something and try and run it on an 800 megahertz processor, you have to make a lot of changes and improvements to get it cut down like that. And that is one of the real motivators for why we're trying to move some of our development to the consoles, is to sort of make those decisions earlier. Yeah.
Can you tell us anything about its next game?
No, I'm really not going to comment on the next game right now. Yeah. No, I haven't done any development on those yet. I just recently looked over some of the PSP stuff with an eye of, we tossed around the idea about maybe taking a Doom 3 derivative to the PSP. I really like the PSP. It's like, I don't play a ton of video games, but I like the PSP. It's one of the few things that I've been playing lately on there. So I think it's a cool platform, and we're looking at the possibility of maybe doing something that it would have to be closer to Quake 3 level graphics technology, because it doesn't have as much horsepower as the modern platforms, but it's got a nice clean architecture. It's again back to one reasonably competent processor and one fast graphics accelerator. So the development tools they aren't up to Microsoft standards on there, so it's probably more painful from that side of things, but it looks like an elegant platform that would be fun to develop something on. Yeah.
You spoke earlier about advanced physics and how that intersects with the work you're doing. How do you feel about the idea of standalone physics cards? How that might impact?
Okay, standalone physics cards. They've managed to quote me on the importance of physics and everything in upcoming games, but I'm not really a proponent of standalone physics accelerators. I think it's going to be really difficult to actually integrate that with games. What you'll wind up getting out of those, the bottom line is, they're going to pay a number of developers to add support for this hardware, and it's going to mean fancy smoke and water and maybe waving grass on there. You're not going to get a game which is radically changed on this, and that was one of the things why graphics acceleration has been the most successful kind of parallel processing approach. It's been a highly pipelined approach that had a fallback. We moved in Quake, Quake, GL-Quake, the Quake 2 timeframe, where we had our CPU side stuff, and then the graphics accelerator made it look better and run faster. Now, the physics accelerators have a little bit of an issue there, where if you go ahead and design in these physics effects, the puffy smoke balls and the grass and all that, you can have a fallback where you have 100 of these on the CPU and you have 1,000 of them if you're running on the graphics accelerator. One of the problems, though, is it's likely to actually decrease your wall clock execution time on there. And this is one of the real issues with all sorts of parallel programming, is that it's often easy to scale the problem to get higher throughput, but it often decreases your actual wall clock time because of inefficiencies in dealing with it. And that's one of the classical supercomputer sales lines, that you can quote these incredibly high numbers on some application, but you have to look really close to say that they've scaled the problem. Where usually people, when you think acceleration, you want to think, it does what I do, only better and faster. And a lot of cases in parallel applications, you get something where, well, it does what I do, it's better, but it might actually be a little bit slower. And this was one of the real problems that we had in the first generation of graphic accelerators until 3DFX really got things going with Voodoo, is that a lot of the early graphics accelerators, you'd take the games, they would run on there, and they would have better filtering and higher resolution. So in many cases they'd look better, but they were actually slower. In some cases significantly slower than the software engines at the time. And it was only when you got to the Voodoo cards actually saying, okay, it looks better in every respect, but it's actually also faster than the software rasterized version, that they became a clear win. So I have concerns about the physics accelerator's utility on there. It's the type of thing where they may be fun to buy for their demos. It might be cool there will be some neat stuff, I guarantee you. I know there's some smart people at the company working on it that I'm sure are going to develop some great stuff, and there will probably be some focused key additions to to some important games that do take advantage of it, but I don't expect it to set the world on fire, really. Yeah, back there. Creative gameplay designing. It was sort of one of my themes about the issues with development on there. And this was another kind of interesting thing with the cell phone project on here. Lots of people will go on about the lack of creativity in the game industry and how we're lacking all of these things. It was interesting when we interviewed at Fountainhead. We were looking for some additional people to bring on to the development team for cell phone projects, and we had several cases of people going, I don't want to work on a little puny cell phone, essentially. Everybody wants to work on the next great sequel. People go into the game industry, they want to work on Doom 5 or whatever, the games that they've had a great time playing. And there's nothing wrong with that, but it was a little disappointing to see a lot of people give lip service to creativity and innovation and being able to go out and try different things. But there's probably not nearly as much when it comes down to actually walking the walk on that. It's probably not as widespread as a lot of people that will just chat on message boards about how awful and non-creative and everything is nowadays. But I do think that, like I said, my key plan is small platforms, maybe a cradle for innovation, and then I leave a lot in the hands of what people can do with the source code platforms that we have released as an ability to kind of strut your stuff. I mean, that's the best. The other aspect of the source code is it's been the best way to get into the industry is do something with the resources that are available out there. If you do something really creative and you get thousands of people playing your mod online and everybody likes it, you can get a job in the industry because that's going to be, those are credentials. That's showing that you've got what it takes to actually take an idea from a concept into something that people actually enjoy. And that's been a really positive side effect of the whole mod community in general and the source code stuff as a follow-on on that. Okay. Yeah. So LGPL middleware solutions. I'm not really up on all the middleware solutions. So are there actually significant middleware solutions that are under the LGPL? Yeah. So I mean, we use OpenAL for some of our audio stuff on there. I think it's a good, the GPL has always been sort of a two-edged sword on there, where a lot of people will just say, well, why don't you just release it under like the BSD license or something, so so we can do whatever we want with it. And there's something to be said for the complete freedom, but I do like the aspect of the GPL about forcing people to actually give some back. I do get a little irritated about people getting too proprietary about their edition of the code when it's built on top of what other people have put far more effort into. But any of the work that goes on for developing the either GPL or LGPL stuff, it's been, to some degree, there's a lot of stuff that goes on in the development of sort of amateur graphics engines that people are doing because it's fun, and it is, not so much because it's going to be something that's really going to help anyone produce a title or do something interesting there. I think that in general, people trying to actually make a difference would be better served working in one of the established code bases because the development process, the last 10% turns out to be 90% of the work. And there have been dozens and dozens of projects that are done in a somewhat public form that look like they're making great progress, and you take a quick glance at it and say, oh, this is 90% or 80% of the way to something that could be a commercial game, when in reality, it's 10% or 15% of what it takes to actually get there. So I certainly encourage people to work inside the context of full complete code bases that have commercial kind of a pedigree on it. But the great thing about any of that, though, is if you just want a program to have fun, which is a perfectly valid thing to do, writing graphics engines and middleware solutions sort of from scratch has its own appeal. What else?
Are there any dreams that you had growing up, in the early days of graphics that, or in your industry in general, that still, despite all this, have not been realized?
The number of orders of magnitude that we have seen in graphics, it's really stunning. It's easy to be blasé about the state of everything, but if you step back and take a perspective look at this, it's like I stand in awe of the industry, of what everything is, the progress that's been made here. I mean, I remember writing character graphic depth buffer on a line printer at a college VAX, or all the Apple II graphics and line drawing and so on like that. I could not say that I envisioned things at the point that we've got right now. I mean, it's hard, like even if you say right now, what would you do with 4 orders of magnitude more performance? I mean, I can tell you right now what I'd do with 1 or 2 orders of magnitude. There are specific things that I know look good and will improve things and do all of that, but just imagining out a couple more orders of magnitude is pretty tough. So I mean, even at the worst of times, I'm a glasses half full sort of person. I mean, this glass is overflowing. I don't have anything that I look at as, darn, it's too bad we don't have all of this. Yeah.
You, in addition to graphics, you also create internet networking code that works with Quake. Now that every serious gamer now has broadband internet access, is there anything else you think that can be done to improve internet networking code, or is that something you just don't think about?
So on the networking side of things, it's been extremely gratifying to see the success of the massively multiplayer games. We certainly talked about doing that type of stuff early on in the Doom days. We actually we started a corporation in communications that was with the expressed idea that we should pursue this type of multiplayer persistent online experience there. And it never got around to all of that. But when the early Ultima Online and EverQuest were coming out, I was certainly looking on that, eagerly anticipating how they would do. And the huge success that we've seen with all of those has been really cool. It's again one of those things that it's not something that we're directly a part of, but I can very much appreciate the raw neatness of how that's all gone. And there are technical directions that things would go if broadband performance continues to improve in terms of bandwidth and latency and variability. There are other styles of technology that one would do to make, you can make cheating, all the client-side cheating things sort of impossible if you had enough bandwidth to essentially have everyone just be a game terminal where you're essentially sending compressed video back to them, so there's no opportunity for driver cheats or intersecting game positions of things. If someone wants to actually write visual optical analysis software to analyze compressed images to target people, go for it. That's a hell of a research project. Something like that would be a direction that things could change. I think that the push that Microsoft's done with Live in a lot of ways has been good, making voice kind of a standard part of a lot of the games, and the work that's going on in terms of infrastructure and back-end and matchmaking. Microsoft's been pretty smart on a lot of things that they're doing there. So we're not, it was a lot of fun doing the early networking development work, but it's a reasonably well understood problem now. I don't expect to see really radical changes in the technologies that are going on in games. It's just gotten easier with the broadband where we don't have to cripple the game or the single player aspect of the game as much now. That Quake 3 was all built around kind of minimum transmit, all presentation client side, and that actually made Quake 3 a little bit more difficult of an engine for developers that took it and made single player games out of it. A lot of times, like some of Raven's titles, they would wind up just making two separate executables, where you take one that's kind of more derived from the Quake 3 original source, and then one that they took a hatchet to make a great single-player game out of. And there will probably be, as people start going through the source code in the coming weeks, it'll be interesting to see what people make out of those necessary trade-offs there. Yeah. Well, we tried to start getting it put together, but everybody's really busy. Timothy's going to be taking care of making sure everything's got the right GPL notices in anything, that everything builds, that the utilities and everything are done. I'm hoping it'll be next week. It would have been nice if we could have had it done actually up on the FTP site now, but things like working on Quake 4 is still taking priority for a lot of resources there. But I would certainly expect within a week. Yeah. Okay, tools and middleware over APIs. There are interesting trade-offs to be made there where for years, the middleware companies were really in kind of a dodgy space in terms of what they could provide and the benefits that you get from that. And it was really only with kind of the PS2 that middleware companies really became relevant for gaming on there. Now, it has always been sort of the champion of full engine licensing. And I still think that's probably, we have no intention of changing from that model. I think that a company will get more out of taking a complete game engine and modifying that to suit their game if they're looking for something that's reasonably close to what the game engine does, rather than taking a raw middleware technology and using that to build a game on top of. Now, the nastier the platform is, the more valuable middleware is. Middleware was valuable on the PS2 because there's a lot of nasty stuff in there that developers didn't want to work with. It may be less valuable on platforms like the 360 that are really pretty clean. There will be more solutions for things on taking advantage of the cell processor, where you'll probably be able to get neat little modules that do various speech and audio processing and certain video effects and things like that, where you just know, I can go run this off on a cell processor. I don't have to worry about figuring out how to do that, and it'll go do its job and add something to the game. So there will be some good value there. It's again, there's definitely a valid place for the middleware solutions, but again, there's been a ton of success built on top of our engine licensing model as well. It's right there. Oh, the Armadillo Aerospace stuff. It's like, well, I can talk for another 2 hours about all the aerospace side of things, but in October, we're going to be flying a little vehicle at the X Prize Cup to show rapid turnaround. The big change that we've made in the last 6 months is we've abandoned our peroxide-based engines and we're using liquid oxygen alcohol engines, which we're still getting them to melt sometimes. That we've got a few issues left to work out on that. But the upsides of it is that it's essentially a combination which you can credibly build an actual orbital booster out of, which the combination that we were using before was optimized for ease of development and to make it generally safer and a lot less problematic for us to develop. But now that we're going ahead and taking that big step of making it work with cryogenic propellants, it'll be the platform that will be able to take us into the future. Yeah. No, okay, I actually just recently sold my last Ferrari, so I've been sort of pawning them off for a while, and a lot of people commented that for a while in my old house I didn't have much space in the garage, so I had my little machine tools, my mill and my lathe, small things, and I would be setting books and manuals and parts on my Testarossa, and people are like, this is just appalling, but it was table space for a while there. But yeah, I did just recently sell the F50. I've been The rocket work kind of drove a lot of vehicle choice, where I drive a BMW X5 to carry boxes around in mostly because I have to lug things around, and it just doesn't work having boxes of industrial parts sticking out of a Ferrari there. And the sporty car, actually my wife's car is a BMW Z8, which is a neat little sports car, and it's not a Ferrari, but it's actually in many ways sort of a more of a fun car to drive, where recently, just before I sold the F50, I drove it around for a little while. It had been in the shop for a long time, actually getting turbos taken off, because the damn Ferrari purists, none of them want a turbo Ferrari. It's like, I don't understand it. You know, they would rather have this, they'd rather pay more for this pure car that you're in danger of having someone with a Mustang and a big shot of nitrous running ahead of you. It's like, that's no way to have an exotic car. But it was interesting to just go ahead and drive it again like that. And yeah, when you run it flat out, it's a fast car, and it's faster than the Z8. But just for most day-to-day around the town driving, the Z8 is actually a more fun little car. The cars that I have fond memories of are things like my 1,000 horsepower Testarossa, which is just a completely different quality of experience. It's not just a little bit faster, it's see God and hope you don't die type of fast. And that's spoiled me for years. It's like forever after, probably I'll test drive somebody's new supercar and they'll be like, oh, this is pleasant. Yeah, done? Okay, one more question. Okay. Okay, that's another kind of good example about how we really need more of stuff. Where if you look at the movies doing facial expressions, they will have hundreds of control points going on tugging every little muscle that makes up the face. And we as an industry know how to do very realistic facial work there if we follow the movie leads on that. But it's time consuming and expensive, and I don't expect radical improvements in that, where if you look at the Lord of the Rings work on there, you get to see a lot of the making of stuff where you talk about how they animated Gollum's face. And it comes down to an insane amount of man work, just going in, tweaking every last little control point. Yeah, they capture most of it, but everything gets touched up. And that's just what's going to be leading us to $100 million game budgets. And these are all the things that, it's not going to be long before we literally see a $100 million budget game that's going to employ all of this level of movie production values going in there.